Hello everyone, welcome back. In this video, we'll be discussing about the last problem of yesterday's biweekly contest, maximize consecutive elements in an array after modification. The problem is very interesting. It is one of those problems where you start with top-down dynamic programming approach, and to actually optimize it, you need to convert it to bottom-up and then play around with the loops to see if you can optimize further. So we have solved these kind of problems in the past. This is one of those problems. I will try to find the previous videos and link them in the description down below so that you can refer. So with that, let's get started. The problem states that we're given a zero-indexed array nums consisting of positive integers. Initially, you can increase the value of any element in the array by at most 1. Now, after that, you need to select one or more element from the final array such that those elements are consecutive when sorted in increasing order. So your task is to find the maximum number of elements that you can select. So given an original array, you have the liberty to increment the value by 1, at most 1, for any element. So you can increment this 2 to 3 or keep this 2 as 2. You can increment this 1 to 2 or keep this as 1. You can increment this 5 to 6 or keep this as 5, and so on and so forth. Now, let's assume that I have decided to increment this 2 to 3 and this 1 to 2. So the final array that I have now is 3, 1, 5, 2, 1, right? Now from here, I select 3 elements, 3, 1, and 2. And if I sort them, I will get 1, 2, 3, which is consecutive. So I am getting 3 consecutive elements, or I'm able to get 3 consecutive elements from the modified array, and the answer here is 3. Note that you can try modifying any other elements, you can try selecting different set of elements, but in any case you will not be able to select more than 3 consecutive elements, and hence the answer, the maximum number of consecutive elements you can select is 3, and hence the answer is 3. So hope the problem statement is clear. Now how to solve this? First of all, the order of elements in the array doesn't matter, right? And because it doesn't matter, we can sort the array, because like solving the problem in a sorted array is often easier than solving in an unsorted array. So because we anyway have to reorder the elements after the fact, like we selected 3 elements and we have to reorder them afterwards. So let's just sort the array initially itself. So now we have this sorted version of the array and we'll work with this sorted version. So let's for now get rid of the unsorted part. We have to create a sequence of elements, right? Now that sequence can start at 1, or it can start at 2, or it can start at 3, or it can start at 4, and so on and so forth, right? So if it started if it starts as 1, basically we are looking for a sequence of elements 1, 2, 3, 4, and so on until whatever we can get. Similarly, if it started 2, we are looking for sequence 2, 3, 4, 5, as long as we can, right? And so on and so forth. So let's assume that the starting element is 1. Again, it can be 2, 3, 4, 5, or whatever, but for now we are assuming the starting element as 1. And we will whatever our task is to find out what is the maximum length of the sequence I can get if I start at 1. That's my target. Now note that whatever I do for 1, I will have to do the same thing for 2, 3, 4, and 5, and we will keep on doing this until all the elements are exhausted, and we'll take the max across all of them to get the answer, right? Now where like till what value we will do this? The maximum value in the array, which is 10 power 6. So we'll keep on doing this for 10 power 6 and we'll stop there. So now the task is, if the starting element is 1, what is the maximum number of consecutive elements I can make? Okay, so this is now the task. So to make this elements, you will have to select some elements from the original array, right? You know that the starting element is 1. So you will say, okay, given this array, if my starting element is 1, give me the maximum number of consecutive elements I can form. Okay, now assume that you selected this element. Okay, if you select this element, that is, you say that, okay, this one I am getting from index 0. So now what you want the maximum length of sequence that you can form starting at value 2. So now you are saying that, okay, I am done with index 1, whatever I have to do with index 1, index 0 I have done it. Now given this array, tell me what is the maximum consecutive sequence I can make, given that the starting element should be 2. Isn't this problem exactly similar to the previous problem? The previous problem was, given this array, tell me what is the maximum length of the consecutive elements I can form, given the first element will be 1. First element will be 1, right? Now after we have done something, now we are saying that, okay, give me the maximum consecutive elements I can form starting from this index, given that the first element that I will select will have value 2. So hope you can see the recursion here. So we are solving the same thing but in a reduced version, right? So let's look at one complete example before we look at the pseudocode of the recursive function. So for now we are trying to find out what is the maximum number of consecutive elements I can make starting, given that the first element is 1, right? So I want to form a sequence 1 2 3 4 and so on and so forth, and I need to find how long I can make this sequence from this given array, right? So we need to find out f of 0, 1, where 0 denotes what is the starting point, starting index after which I am allowed to take elements, right? So we are simply saying, starting at index 0, what is the maximum number of consecutive elements I can form given the first element should be 1, right? So that's what f of 0, 1 denotes. Now from here you have two choices for index 0. Either you will take it or you will not take it, right? So let's say you don't take it. You are saying that, okay, I will not take index 0 at all. So what is your new problem? The new problem is, starting at index 1, give me what is the maximum consecutive sequence I can form such that the first element is still 1, right? So f of 1, 1 is what you are looking for. Now if you decide to take it, let's say you decide to take the first element, so you have to first check whether it is possible to take the first element or not, right? So you want the first element to be equals to 1. So if you take this element, this better be equals to 1, otherwise you can't take it, right? So it is actually equals to 1. Even if it was 0, you should be able to take it, because notice you have the power to increment any number by 1. That power you have, you can use it. So either it is 0 or it is 1, then only you will be able to take this particular element, and in this case it is 1, so you will be able to take this element. And if you take this element, what you want what is the maximum consecutive number of elements you can have starting at index 1 such that the first element is now 2, because you wanted to form a sequence of 1 2 3 4, right? And you have already picked 1 from before. So now the sequence now you're looking for should start with 2. So now you're saying, starting at index 1, give me the maximum number of consecutive elements I can make given that the first element starts at 2, right? So let's now calculate the value of f of 1, 1. So starting at this particular index, I wanted to find out what is the maximum number of sequence I can make, maximum consecutive sequence I can make given the first element is 1. Again here you will do the same thing. Either you will take this element or you will not take this element. Now if you don't take this element, the answer is simple, f of 2, 1, right? But if you take this element, you have to first check whether it is possible to take this element or not. In this case it is indeed possible, because the value you are looking for is 1 and you can make 1 from index 1, right? So because it is possible, so you will say, okay, I will take this element, and if I take this element from starting at index 2, what I want what is the maximum number of consecutive elements I can make given the first element should start with 2, right? So similarly, from f of 2 comma 1, you will do the exact same thing and you will keep on expanding these things. So let's look at f of 3 comma 2. That's an interesting one. So we need to find out what is the maximum sequence of elements I can form starting at index 3 given the first element should start at value 2, right? So again, two choices, either you will take this or you will not take this. If you take this, if you don't take this, you want what is the maximum number of maximum consecutive element sequence you can form starting at index 4 given the first element is equals to 2 itself. Now second thing is you want to take this is 1, but you want your sequence to start at 2, so you want a 2 but you have 1 here, and notice you had the power to increment 1. So even though it is 1, you will say okay, I know that I can increment it to 2, so this is still possible it is still possible for me to get a 2 from this index, so I can take this index, or this is a valid choice. So I will take this index, and the next element that I'm looking for is 3, and I should start from index 4. So index 4 starting at index 3, right? So based on this, once you reach 5 or let's say 4 here, so here you are looking for 1, right? So either you will get 1. So can you get 1 from this? No. So the value of f of 4 comma 1 will be 0, right? Now f of 4 comma 2, can you get 2 here? Yes. So the answer would be 1. f 4 comma 2, answer would be 1. 4 comma 3, answer would be 1. Why? Because you can make 3 from this 2 as well. Now what is the answer for f of 3 comma 1? Max of this comma this. Notice that here you haven't taken any elements, but here you have taken index 3 as well. So you will say max of 0 comma 1 plus 1, which is 2. So max of 0 comma 2 will be 2. Similarly here you will do the same thing. You have taken this element, so this is just, you have not taken any element in this path, so this is 1, but you have taken index 3 here, so this is 1 plus 1 2, so max of 2 comma 1, which is 2. Now same thing, you haven't taken any element here, so this is 2. You have taken index 2 here, so 2 plus 1 3, so max of 2 comma 3, which is 3. In the same fashion you will compute everything, and finally you will get the value of f of 0 comma 1. So notice f of 0 comma 1 was just what is the maximum consecutive sequence of elements you can get starting at index 0 given that the first element is 1, but the first element could be anything. First element could be 2 3 4 5 6 all the way up to 10 power 6. So you have to do the same, you have to repeat the same exercise for f of 0 comma 2, f of 0 comma 3, f of 0 comma 4, and so on and so forth until f of 0 comma 10 power 6, because 10 power 6 is the maximum element that you can have. So hope this solution makes sense. Let's quickly look at the pseudo code. The pseudo code would be exactly similar to what we just did by hand. We have a function index comma start. Index denote what is the index I can start the sequence from, and start denotes what is the value I can start the sequence from. So if I reach end of the array, then I can't take any more element, right? So I will simply return 0. Now if I am not at the end of the array, there are two choices. Either I will skip the index or I will take the index. If I skip the index, the maximum number of elements that I can make is f of index comma 1 plus comma start, right? But if I take the index, then there is a choice. Whether to take the index on, whether we can take the index or not is also a question. So you can take the index only when you are able to satisfy this start. The next element you want is this particular value. So if you are able to satisfy this value itself, then only you can take the current index. So either the value of current index should be start, or the value of current index should be start minus 1. In these two scenarios only you can take the current index, and if you can take the current index, you will say you have taken one index. Now starting from the next index, you want the maximum number of elements that can start at start plus 1, right? So once you go through this equation, you will get the value of f of 0 comma 1, and then you will call the same function with for f of 0 comma 2, and so on and so forth, and finally you will take the max across all of them, and that will be your answer, right? Now what is the overall time complexity? Notice if you do this naively, this will take exponential time, because you can see the same state you might have to compute again and again. So f of 3 comma 2 you have to compute again, so you might have to expand this again, right? So you might have to compute the same state again and again. So let's optimize this by just simply doing a memoization. You can simply add a line here saying that if I have computed this value, let's say you maintained a 2D array with I and start, you will say if this exists, then I'll simply return the value that exists here. Otherwise, I will compute this and also store this at the end. So simple memoization, right? Now, what will be the overall time complexity with memoization? So with memoization, we are assured that we are computing one unique state only once. So even if we get f of 3 comma 2 two times, second time we get this, we'll simply have the exact value here. We don't need to expand further, right? So what is the time complexity would be the number of states multiplied by what we are doing in each of the state. So number of state multiplied by what we are doing in each of the state. So let's forget about state for now. What we are doing inside each of the state, we are doing some mathematical operations, right? We are comparing two things, then we are also doing a max, and then we are calling a function. So we are doing order one operation for each state. Now how many states are there? Number of distinct states would be number of distinct value of index, which is n, multiplied by number of distinct value of start, which is let's say v denotes the value, max value of the start. So the complexity currently is n into v, where n is the number of indexes and v is the max value. So max value is 10 power 6, number of indexes is 10 power 5. So obviously this will not pass. So here we need to optimize. So optimizing this is a bit tricky, because if you look at the recursive function, there is nothing, at least trivially you can't see any optimization directly here. But notice that there is a pattern. You are only looking for index plus 1 every time. So there might be an optimization possible if you convert this to bottom up. Now how to convert top down to bottom up, we have discussed multiple times in the channel. The simple strategy is whatever is the base case, you start from there, and afterwards you just copy paste whatever you have inside this function, right? So if you do this trick, so in this case the base case that we had was if the value of index is n, then we return 0. So we'll simply fill dp of n to 1 2 3 4 everything to 0, right? Now we will start from n minus 1 and we'll go all the way to 0, right? And inside this we have to calculate for each of the start value as well. Now what will be the value of dp of I comma start? This will be exactly equals to this function here. So whatever you have here, you can just copy paste below to get this value, to get the value. So the value of dp of I comma start, which is in this case answer, is equals to dp of index plus 1 comma start. So dp of I plus 1 comma start. Otherwise we'll check if start is array index or array index plus 1. We'll do dp of I comma start is equals to max of dp of I comma start comma dp of I plus 1 comma start plus 1, right? So exact same thing we have done. Now this is the bottom up solution. So I would strongly encourage you to pause and try to see if you can observe some pattern here or optimize this entire thing with some observations. So hope you thought about it. The simple thing here is, notice we are iterating over everything, and what we are doing, we are assigning dp of I comma start as the same value as dp of I plus 1 comma start. That is fine. Now in which case this assignment might be changed? This can be changed in two conditions, either when start is equals to array I plus 1 or when start is equals to array when start is equals to array I or when start is equals to array I plus 1. Only when start is these two values, then only we may change the value of dp I comma start. Otherwise dp I comma start will always be equals to dp of I plus 1 comma start. Okay, so notice we are only changing the value in two conditions, when start is array I or when start is array I plus 1. So why to iterate over this iterate over all the start again. Can't you optimize this? Again, time to pause and think. So let's look at the final conversions. So this was the original algorithm that we had. So notice we are assigning dp of I start with dp of I plus 1 start. So basically at any given point of time we only care about the next value of the dp, nothing else, right? So we can simply skip saving all different values for all different indexes, right? So we simply drop this second dimension, first dimension from here, and say dp of we'll maintain one dp, and because there is just one dp, whatever dp was there at I plus 1, the same will be applied for I. So now this is implicit. This assignment we don't need to do anymore, right? So we just simply remove this and everything is still the same, right? Now finally the complexity is still not order n, it is still order n into v because there are two loops, right? So notice we are only modifying something, or we are only doing something when start is either array I or array I plus 1. So why even iterate over the entire start? So we can simply remove this loop and only consider these two cases explicitly. So when start is array I, this will be the state. When start is array I plus 1, this will be the state, right? Now if you look at, the complexity is just order n. Okay, so hope you understand the solution. If you have any doubts, feel free to rewind and watch the previous section. If you have watched to this point, I would strongly encourage you to pause and try to code this entire thing by yourself. Also try to understand how we have went from the journey of the top-down solution to this recursive and then finally optimizing it to order n, because that's what will help you in future problems as well. So next we'll be looking at the code. The code is very straightforward here. We had just this dp array which consists of all the values till 10 power 6 plus 2, and we initially sorted the array as well, as we discussed. Now we start from n minus 1, go all the way up to 0, and only change these two values here, and at the end we will just take the max across all the dp values, and that will be our answer. So why we are taking the max? So notice what we wanted to find. If you remember, we wanted to find the max of f of 0, 1, f of 0, 2, f of 0, 3, all the way up to f of 0, v, right? And we wanted to find the max of all of them. So what is f of 0, 1? It is dp of 0, 1, right? Similarly dp of 0, 2, and so on and so forth up till dp of 0, v, right? So if you remember, dp of 0, v, we have dropped this particular index from here, right? So dp of 0, v will always be there at the end. So when you have completed this entire loop, at the end what you have is dp of 0, whatever is the value of dp of 0, I, where I is between 0 and v, will be the current dp array, this one dimension array, right? So this dp array is dp of I is equals to dp of 0, I, and hence we just simply take the maximum across this dp, and that will be our answer. So again, if this part is not clear, just try to think what we have done in this optimization. So we saw that we have dp of I comma start is equals to dp of I plus 1 comma start. So we saw dp of I comma start is always equals to dp of I plus 1 comma start, except two things. So let's completely remove this and just maintain this one dp, and because we have just one dp, whatever the value was there previously is the value currently as well. So there is no assignment required now, right? So when you move from I to I minus 1, whatever the value at dp of I was, it will be the same at dp of I minus 1 as well. Okay, so at the end you just take the max across all the dps, and that will be your answer. So hope the entire session makes sense. If you have any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.